he will join in lah. All right. Okay. Right. So welcome to today's session, Noel and Farah. All right. So in terms of practical, I hesitate to actually do the practical because we haven't finished the wide area network lecture actually. But maybe I'll just upload the practical later, right? So maybe we continue what we were doing yesterday, okay? Going through the tutorials, right? As part of your preparation for this evening, yeah? This evening test lah, okay? Right, so let me just set share the. Is that okay with you guys?
Okay.
All right. Yeah. And obviously, during our session today, if you have any questions regarding the any questions from the tutorial or your revision, right? Um, feel free to let me know, lah. Then we'll discuss. Okay, so let me just share. I think tutorial one. I think we left it here yesterday. Okay, so when it comes to here, you need to know. I was talking about yesterday. You need to know the create a default static route. Okay, and if I remember Noel asking only when the question really asks for fully specific, sorry, fully specified static routes, then you do it now. If not, just assume that it's standard static route. Okay, and yeah, based on the question lah, whether the question wants the full one or not. And guys, you need to know how to create uh, using IP version 6 as well, yeah. Okay, just in case instead of IP version 4, it's IP version 6. The floating route, right? The floating route, basically just put in the AD, right? Anything higher than 1, I think, becomes the what lah, secondary. So let me see again. Apart from that, I think, yeah, I mentioned about here, right? Okay, so when you look at this one, to identify the remote network, any network that's beyond one hop, let's say under consideration is this one, router 2. So anything that is connected directly to the router will be directly connected. So that one, automatically the router will insert entry into its routing table, okay, because it's directly connected, so the router knows about those network. What the router in question doesn't know is when it's one hop away or more, one hop or more away. Those those remote networks won't be known by that router. So that means if it's static, means you have to put it in yourself, lah, right? Put it in yourself. That means in order to be able to route or forward packets to that particular remote networks, then you have to specify lah, right? The address of that remote network plus the interface that it needs to that leads to it lah, right? Okay, so for tutorial one, it's all about this, and make sure you know how to do, okay, this part, this tutorial, because the coverage will include this, okay. Right, so let's go to tutorial 2. Let me just go through to see. Okay, let me just double check here. With reference to this figure, all the routers have been configured with or OSPF. So OSPF um, is an alternative to EIGRP, right? I believe in CN you already touched on EIGRP. So now is OSPF. OSPF is also for sharing the topology, the routing table between routers. Okay, so it says routers have reached convergence state. So these are all the commands to just basically show content, right? So show IP interface brief for R1, R2, R3, and it shows here. All right.
So
Yes.
what's presenting?
I'm not presenting, is it?
Yeah,
Oh,
still in the Google Docs.
yeah. It's actually should be going to tutorial 2, so stop already. Right. So describe the precedence how the router derives router ID. So router ID is one of the ID required, right, for OSPF, right? So how the router gets router ID is shown here by Farrer, yeah. Okay, using the OSPF router ID and then the value, the number, right? Highest IP version for address of any loopback interface. This loopback interface um, is, if you recall, can be created in the router, right? And usually it's the best if you use the loopback interface, you provide an address for it, and it's best that you use the loopback interface IP address to connect to that for management purpose. If you want to connect to a router to do management, it's better to use the loopback interface IP address because it's always there, right? Um, Recall that router different with switch router have interfaces, and interfaces, the physical interfaces can be assigned IP address. Theoretically, you can use any of them to connect to the router. But the thing is, if you use that, okay, you're vulnerable to the fact that any one of those physical interface can go down or being shut down, right? Of course, loopback interfaces need at least one interface up, and that you can reach the router. But loopback interface is a steady interface, means it will not change until you change the IP address, right? That's one of the benefit lah. If you want to use loopback interface, you know, it doesn't go anywhere, but it can also represent a place for you to um, you know, to for testing purpose also lah, right? Okay, so precedence is the router ID, and then if not available, then the highest IP version for address on any of the loopback interface, right? So if this is not provided lah, and then you look at this, okay, and then if that's not available, that means loopback interface is not created. Then highest IP version 4, that is no shutdown one active on any of its physical interface. Okay, that becomes the router ID. So identify router ID for R1, R2, R3. Basically, you're given. So based on this, then you choose what is the router ID for these three router. I believe there is a loopback. So whenever there's a loopback, you choose loopback. If there's no loopback, then you choose the highest physical IP version 4 address, right? So referring to the network topology, will a designated router and backup designator be elected? Justify your answer. Right. So we actually only need DRBDR. In the first place, why do we need DRBDR? Because the designated router becomes the one that is the router that will share the info. And backup router will only come into if the designated router is not available, right? Right. So, but it's only for multi-access network. If it's a point-to-point network, means a point-to-point link, then there's no need to have DR BDR because there's only one sharing to the other one and the other one sharing to the other one, right? But if your multi-access means more than two router, then DR BDR election will happen, right? Okay, so refer to OSPF configuration shown in figure 3.2 or 3.1? 3.2, right? 3.1. Configuration. Where's this configuration? This one. Configuration. And the network topology here, shown here. Answer the following question. Again, determining the router ID based on these three, one after another, right? So I think that's straightforward. Farah already answered that. Refer to figure 3.31 and figure 3.2 and rectify any OSPF configuration error. Right, so in OSPF 1, the IP route to network area 0 is misconfigured. Let me recall first. Router OSPF 1, area 0, 10.1.2. This not subnet mask. This is wildcard. You guys know how to calculate wildcard. If you're not sure, there's always a wildcard calculator so online. But for final exam, you don't have access to the wildcard calculator. Okay, so you still need to know how to do it by hand. Just basically to use the formula deduct from the subnet mask. But for purpose of quickly getting the answer, you can use online because it's online. You can use online calculator, online wildcard calculator. Okay, if you want to get the calculator, right? But still, you need to know how to do it, because for final exam, you have no access to it. All right. So it says router OSPF 1, 10 32000, and this one is 10.1.2. That's okay. This one 10.32000.0.255 area 0. So you remove that, change it to 2.1 because I believe the network. Yeah, 10.3.2.1.0. The 10.3.2 here. Okay, there's a typo. So to remove config, put no in front, and then redo it with the correct value. Okay, so this command here to access the router configuration, so that you can perform these two command, right? All right, so part C, refer to network topology shown in figure 3.2, provide two reasons why it is recommended to set interface G00 on R1 to passive. Because G00 on R1 passive, because we're not connecting to another router. Okay, so whenever the interface is linked to directly to PC, for example, so to prevent the DR pushing, sharing info down this interface, put this command lah, right? Passive, to make it passive, right? Right, prevent unnecessary traffic. That unnecessary traffic is because there's no router on the other end. It's an end device already, and also it could be a host or it could be a network. No need to send OSPF information down that interface. All right, so configure that to passive interface. Right. Okay, so the second reason is basically the same, right? This one, but now the reason is the network still can be advertised to other routers, right? Okay, once it's passive, it's not receiving any OSPF info, then a hacker, because you see, end devices go all the way to layer 7. So that means application. That's the highest layer already, which means the attacker can emulate any software, including OSPF software. Okay, so if you don't put it passive, it's still receiving. So as an attacker, I can use any of the end devices in that network to basically pretend to be a router and send OSPF, and OSPF info will then poison the rest of the configuration, or OSPF configuration for the rest of the routers. So if we put passive, it's not going to receive, it's not going to send, it's not going to receive OSPF info. Thereby, you can then secure, okay, secure your OSPF configuration. All right. So that's what it means by this part. Right. So multi-access network can create two challenges for OSPF regarding flooding of LSAs. What are these challenges? Creation of multiple adjacency, right, and extensive flooding of LSAs. Right? So this happens whenever there's a change in topology. Change in topology simply means when you add in another router or remove another router, or something down lah, the route, one or more routers going down. So the topology change will initiate OSPF again, right? Okay, and multi-access means you have more than two routers. Therefore, um, the, all of them will try to exchange information, LSAs, between them, right? That's the challenge, right? So in a multi-area environment, it is normal that link state update overhead is high and spare calculation run. No, it's not normal because we want to avoid that actually. So that's why answer no here, right? Okay. So it is normal, it's not normal. Calculation run frequently. Disagree because it's abnormal. When a large OSPF area is divided into smaller areas or multi-area, the link set update overhead should be low, less routers. Okay, if you divide it into multiple OSPF, right? But multi-area OSPF is useful in larger network deployments to produce processing and memory overhead because there are fewer routers exchanging LSS. So you basically, instead of a single area, you have multi-area. That means you do, when your group of routers become big, right? More and more routers, you should then consider multi-area rather than single area. Okay. Network associate is troubleshooting OSPF config in two routers. Okay. FAC and FIB. The routers are unable to establish an adjacency between them, right? And then we do this command for router FAC and FIB. Then we identify errors, propose solution. So on FSC, the command show IP or SPF in interface show this, and then for FIB it shows this. Right, so you can see it says here Kelvin. Right, so I think this one not marked yet. So let's mark this. Right, so it's question 5. Okay, I actually it's highlighted already. Oh, highlighted already in red. Okay, but that's the problem lah, right? It should be the same. If you want them to be adjacent, to be able to create adjacency, this setting, the hello and dead timer should be the same. Okay, Kelvin.
Yeah. Is it correct?
So, mm, so hello and dead interval of should be set to default of 10 and 40 respectively. Well, in fact, the priority should is okay. No worries about the priority. So yes, you can. Let me just grab a tick. So this one is correct. Okay. Or or value of 5 and 20. So it's up to you lah, whether you get this as canon or 5 and 20 as canon. But either one can. But if when you choose one, then both must be the same, right? So it can be both 10 and 40 or 5 and 20, right? Okay, so this is number 6 with reference to this figure. What is the default interface priority for R1, R2, R3? All right, so Ferrer said 1, which is correct. Okay. And then what is the router ID? Again, use the previous one to what? This one is R1 is this, correct. R2 is this, correct. And then R3 is. So basically, Noel just pick all the loop interface IPA version 4 address. Which router are DR, BDR, and DR others? Right. So R1 is DB. The let's say R3 is DR. Yeah, correct. And then R2 should be DBR,
Or
and this one should be DR other. Yeah, others. So this one R3. Cannot see you. Can you guys? Good. You
I
can
just
see.
reference Noel one, the ID of Noel.
Yeah, can see. Yeah, should be okay lah. Can see. All right. So Farah modify the priority interface priority to make R1 a DR and R3 a BDR. So kasih terbalik lah, right? R1 become DR and R3 becomes DBR. Okay, so what's the rule to be DR? It means router with the highest router ID, right? So instead of relying on router ID, we can also set interface priorities, right? So that means then we can allow a router to be DR, and the other one becomes DR other. Yeah. Okay. So right. So let me just put in that comment. Then Just all right. Okay. So to set the priority of an interface, use the command IP OSPF priority value. The value is between 0 to 255. A value of 0 does not becomes a DR or BDR. A value of 1 to 255 on the interface make it more likely that the router becomes the DR or BDR. Right? So the commands being used to change R1F00 interface priority to highest negative 255 and make R1 a DR and then reset the OSPF process. So I give you the command. Let me see. Just get the use Ubuntu Monua. Okay. So this is the commands that you can use, right?
Okay.
So and then this is on R1. So let's go for the next one. Yeah, again. For R3, do the same, but then the priority, change the priority lower. Okay, something like that. Similar, just priority is different. So that means this R1 become high priority, then it becomes DR. All right. Number 7, a network associate is troubleshooting the OSPF configuration of router R1 as shown in figure 6.1. The router R1 could not have the OSPF enabled with the assumption that the configuration R2 are correct. There's no hardware problem. Evaluate the possible cause of this problem. So looking at the 4J, looking at the values, let's have a look. No said R1 and R2 does not have the same hello and I have same hello and how do you know?
Because you said
Is it shown here?
evaluate the possible cause.
Okay. R1 doesn't have a router ID. Interface, no IP address. This one is so working on IP version 6. Yeah, doesn't have a router ID. All right, so here is IP version 6. Remember how we enable the router ID. So router ID, so yeah, doesn't have a router ID, but that's not the only thing. If you don't have router ID, what happened?
Automatically.
Then the next one is what? To check what?
highest IPv6 address.
That one is the third one. The second one is
Uh,
means you need to see whether there is any loopback interface, right? If router ID is not configured, then it falls back to loopback interface. Then we look at it, can there's no loopback interface on R1, then it will fall to IP version 4 address. But you can see there interface fast Ethernet 00 on R1, no IP address. We have IP version 6, but no IP version 4 address. But the OSPF needs this IP version 4 address. Says there are no, say no, nor. So there is no way to get what OSPF enabled because it cannot. It fails on this. Okay, there's no router ID, then it goes down here. There's no loopback interface, it goes down here. There's no interface being with IP version 4 address, then there's no more. Then it fails. Is that okay, everyone?
oh, so the router ID cannot be in IPv6.
Yes.
Oh, okay.
Right. So is that okay, Kelvin and Heather?
Okay.
Right. So we go to question number 8. Based on figure 1.1, determine OSPF using network command configurations in Edge and FOCS Edge with Edge and FOCS router to allow PC1, 2, 3, and any PC on the internet to communicate with each other. Use OSPF process ID 54 and area ID 0. Configuration of default static route completed in the respective. So don't forget you have to put static routes also. So, okay, so Kelvin and Farah, right, not yet configured. So let's do, so Kelvin do Edge and Farah do FOCS. You guys know how to configure OSPF? Kelvin and Farah?
Oh no, I hold on.
Right, so watch carefully, yeah. You might need to do this in the test. So you basically need to type router OSPF. Now it's already given the value, which is 54 OSPF process ID 54. So 54, right? So while I'm showing Kelvin, Farah, can you duplicate on FOCS? Okay, so now that you have created the OSPF, then we need to enable, yeah, same lah, because they belong together, a single area. So Farah is the same process ID. Yes, same, yeah. So the question will give you that value, and then you should need to follow that value. So next, we want to be able to, let's look at here again. It says we want to enable PC1, F2, 3, and any PCs on the internet. That means here, go to internet and any PC on the internet to communicate to each other. So PC1, 2, and 3 need to go internet, right? So network 172.16.12, right? Need to go to the internet. So we want this one. So we type network 172.16.12.0, and then the wildcard any PCs, right? Right. So that means this line will allow these PCs to communicate. Right. Now for the edge also we need to allow these two networks. So we need to do summarization. So summarization, let me just root summarization it. Okay, so what we have is what's the first address? Why do we need to do root summarization? Because I can see that it's 192.168.44.0, 192.168.44.0, 192.168.44.0, and then the other one is 55.0. So the root will be 44 to 55. So 0, 55, 0. Did someone message me? Yes. Hang on. Let me confirm. Yes, Noel. So you have the, so basically, so for Farah, no need to summarize, Farah, because yours is FOCS. Okay, so FOCS, you do two network, one for each network. Okay, you can try to do it. Okay, you did one for 44, you try to do the one for 55. But for Kelvin, we need to do the oops, sorry. This one, let me just check. Hang on, this is 1, 0 or 1. Let me just check. Let me just do calculation, quick calculation, binary calculation. So if 172.192.168, with me, Okay, so all right. So I actually we don't need to summarize that. No?
Oh,
Yeah. So we don't need to summarize. We just take the network here 172.16.1.0. All right, and that's it actually. 172.1.6.1.0. Okay, here. So and then it's slash 30. So slash 30, the wildcard for it is 30 is 24. 1, 2, 3, 4, 5, 6, 6, 30. Yeah, just so 1, 1, 0. Hang on, huh? Okay, got it already. Because this is slash 30, so the minus 1255 will be two bits at the right hand most, so it's 0, 0, 0, 3. Okay, recall that this is slash 30, right? So the welcome will be 0.000.3. Now don't forget this one is area. What is the area ID provided is 0. So area 0, and here as well area 0. Okay, now because this there are two network at the back here after FOCS, right? So for Kelvin part here, Farrah no need. We have to put before information originate. Okay.
Sorry, what's the reason again? To
What is the
Yeah, sorry.
what is the default information originate?
Yeah, that is a special command to generate a special route. Sorry, a default route. Okay. So that means if it doesn't match any of the, it's incoming from there, right? That area. If it doesn't match, then it's a default route. So I can just give you this one from Cisco also. Share with you guys. I share directly in the what now? Here. It's right. Why is this all in bold? Bold. I pulled that one. All right. So
oh,
okay. So whenever you have this scenario where you have it wouldn't match if you go to it when this traffic here will come here, it doesn't match, right? Then it will pass this as a default route. It's going to be forwarded, right?
oh, okay.
Okay, because here it will forward when the FOCS receive this, it will forward, right? Okay, and when the edge receive it, it will just because default route, right? Because it forward to the internet lah. This one considered as internet, right? So let's have a look for Faro router OSPF 54. That's correct. Network 192.168.44.255. Area 0, correct. 55. Another one, Farah. Can you add on top here for the? Oh, I didn't see the rest. Okay, that's it there already. 172, 1610, 003, area 0. Oh, okay, that's right. Okay, because this one also connected to the FOCS router. All right, so now it's okay. Sorry, I didn't see it at the back just now. So this is correct, 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 correct. And here is it's all correct also. So uh, make sure you guys know how to do this part, right? Um, the Let me just think about it. This one. Let's give the link first, and then just think. Hold on, guys. Let me just double check something first. All right, so if you want to see the default route propagation, where we use the default information originate, it's in slide 56. Okay.
No.
Which chapter this?
This is chapter 2. Okay. Some information on that just now Kelvin asked. Then let me just quickly check something. Huh? This configuration. Part 2, yeah, part 2. Chapter 2, part 2.
Oh.
Okay.
Yeah. And then let me just go to part 1 to check. Mm. Okay. Okay, let me just check something, guys. Hmm. Okay. All right. I think that's it. I'll confirm all this one correct lah. All right. So any questions here?
In the chat box.
Yeah. Yeah. That's right.
Oh, okay.
Because it propagates the default static route from other router. So maybe I just add in here. Okay. All right. So do understand this part, how to do this part. Okay. Okay. So now I think we're done with OSPF. Let's go to tutorial 3. All right. So tutorial 3 basically just a lot of theory, right? Okay lah. This one. Seems like all you guys okay. So attacking, we have how many types of attacks do we have? One the ask here is, apart from social engineering, we have the denial of distributed denial of service attack or denial of service attack. And what is the other attack?
Malware.
Malware is a type of attack. Let's see, let's open security concept, chapter 3. Right, so under 24 common network attacks. Right, so there are 3 reconnaissance attack, access attacks, and denial of service attacks. There are 3 types, right? Okay, so I think any question on the chapter 3, chapter this one, network security concept. This one is mainly what lah, right? Should be okay for you guys. Are you guys okay with tutorial 3?
I think okay.
I think okay.
Kelvin?
Yeah.
Yeah.
All theory.
This one all theory, right? Okay, so we move on to tutorial 4, the ACL. So ACL, I believe we only reach up to here. We need to mark this.
So you're not presenting the screen.
Oh, sorry. Yeah, up to here. Right, so we proceed with this lah. So Farah also the page 58, 59 not yet done. So I think here while I'm marking this, right? We've done this one like this access. This is access list, right? And then extended. We use this one with a name, right? So that's the difference lah. The standard access list is using number value, okay, to identify, and then for extended use the access list name, right? And only for extended, I think you are able to do this one under Noel's work here, right? So here, specific port lah, specific application, right? So when you ask to do, depending on the question, okay, sometimes you can put in the name, right? Because these are standard port, I think well-known ports. So you can put www, or you can put in the value. If you put the value, for example, www is 80, right? Or HTTP. Is www or HTTP? Yeah. www, right? To be safe, if you're not sure, put the port number there. So for www, whether it's www or HTTP, then 80 covers both lah. You can also put the port number directly, right? So for example, for the HTTPS, the secure version, then it will be 443, for example. Then, up to you lah, what you want to put. But this part is available to specific application, to block specific application or allow specific application, right? And then what else can I think about here? I think that's it. Of actually for access list, um, I think that's it. Then whether you want to use a specific host, you can put in a specific host um, address, or you put if you put specific uh, um, the keyword host, then you don't have to put in the I think subnet mask. If you put sorry, the wildcard. If you put don't put the host, you have to put in the wildcard. But again, check the question. If the question wants you to put host keyword, then put host keyword. If not, then up to you, put host or not, right? Or then if you not put host, then you put wildcard after the IP address, specific IP address for host. All right. Always remember at the end of the access list, of any access list, there's the deny any implicit filter. Okay. So for this ACL, do you guys have any difficulties or not? Any
So far, no.
This one should be straightforward also again. All right. So Farah haven't done this part, so Farah will do. So before I mark, then I check this one. It's already checked. So I check this part. This part, problem number 11. Let me just, some belong to Kelvin. Let's see. Okay. This is page where, this one, page 48, 51. Question, problem number 11. Or problem 10, not finished yet. Right, so media center. Okay. Okay, that's correct. So 11. Router for 11, putting at router B. Just open the workbook. Okay. Yeah. Problem number 11, right? Okay, so write an extended access list to permit the first three usable addresses in this network to reach 172.22.75 network. So you want to look here. So this part, this and this. All right. So permit. I'll keep in mind that the multi-ways is ACL can be written. All right. So this one. So where should we place the ACL? Because we want to prevent any other only we want to permit only the first three usable addresses in the 192.16.20 network from here. Should we put the ACL here or here? What do you think, Calvin? Should we block it at the source or allow it to be processed here, here, and then go here?
Should be at the source.
Yeah, should be here again. This interface.
Yeah.
Right. So then we filter it. If it fulfilled this, then it's not even allowed to be processed at router A. So should be this one. Should be A, huh? You can change it.
Okay.
Mm. And then the interface will be at that interface. So that means block at here, the filter here, right? FA00 at router A. Okay. And then access list should be whatever 111 should be okay. Okay, anything between 100 to 199 should be okay. So let me just get this. Right, so now we create the access list. Okay, the first one is it says that permit the three usable, right? Okay, the first three usable address in 192.16.20. All right, so user access list 111. Deny IP 23 and then 172.75. Why you filter this one 255?
Let me double check the.
I think it doesn't specifically say only up to the to we have to
Until
match.
one
We have to
seven
match
one
until
seven one
yeah,
seven.
until we have to match until
But I
7.
but I write there already.
Hmm?
I write there already, right? 172275. That one subnet mask only.
Yeah, but why is this wildcard there? That means you allow any of the don't care is ones, right? The mismatch is 0. So this one don't care. You're saying this octet don't care. We can match any.
I don't understand.
Now, why do you put 255 here in the third octet? You want to wildcard means if 0 means match exactly, right? And then 255 is the don't care, right?
Oh,
So that means if you put in the third octet as 255, it means for the third octet, match any lah, right? So that means this not necessarily 75 also can. But we want to exactly this one now. Because it says to reach the 172.22.75 networks, we only want 75 network. So this one should be 0. Match exactly this.
oh okay.
Do you get it, Kelvin?
I think so.
Yeah. Okay. So oh, this one, yeah, don't change the last part. The last part, any address within that network. This one we need to match exactly. Okay. But this part can be any value lah. Can be any value. So that's why we put 111 there. 255 means all ones. That means can match any value. If we want to match network only, then it's 0000, and then any value means any value here lah, can match. So because you can see here, it says to reach this network. So within that network, it could be there's be 1, 2, 3, 4, 5. So until 254, including broadcast 255. So for this last octet, we allow any lah, but this must match. So that's why it is 300. Okay. Okay. So this part okay.
Okay.
So let's revisit this one because the question is, it says because we're doing deny first, right? So 192.16.20.4, between that to the range until here. So we first put in one what you did. Okay, 192.16.20.0, and then we need to filter. Okay, that means our wildcard must match. Sorry, this one, this range. So let me get back to the. Let me just type in 192.68.20.4 until 192.16.20.31. All right. So it should be. No, this one is wildcard. No. So 4 and 31 is so if I put in 31, okay, right. So to deny to deny the rest, that means our filter should be using the 31. Our wildcard lah, 31. So 31 means you will ignore the first and then yeah, right. So 20 means it's 0000 until 31. So since we have to permit, all right, so we have to permit first before deny, right? Permit the IP first. We permit the three first, then we can just using the wildcard 31, we can just deny all the way to 31 and allow the rest. So let me just put in 2, 16, 20, 0. So this one is 0.0.0.3. And we allow that to the same network. If we permit that, then we deny the rest. Then we go back here, permit all other traffic. Will be this permit any. So this one caters for the oops, sorry. This one cater for the three usable addresses. First three means 1, 2, 3. Then here from 4 to 31. And then the third requirement, permit other traffic. Is that okay? Kelvin?
Oh, got two things need to do.
Yeah.
Oh, I missed one.
All right. So let's look at number 12. Okay, number 12. This is extended access list.
Why 31? Not 20 point. Not 20.4 and then 28 and then 27.
No, because the three already allowed here.
Oh, okay.
The three allowed, and then denied. Denied means the range just add in. Once permit, it will be permitted, and then deny list, and then permit the rest. Any
If you permit first and then you deny the same things, doesn't it? Is there's no problem since you
should be
permit.
not, because it works on the rest. That means access list work on
Oh, okay.
yeah, you permit and then you deny the rest. So even if you deny from 0, it's already permitted a 3 up there.
Cannot override it.
It's not gonna override, because you see if you say override, then the implicit deny any at the back will whatever you put also it will be denied, right? So it's not overwriting.
Okay.
It's more like a Venn diagram now.
Oh,
Okay, it's the remaining IP address will be applied on. Okay, remember this, or else there's no point we put all the access list, because at the end still deny any is implicit. That means whatever filtering you put here, then whatever not covered by the filtering here will be denied. But since at the end you permit IP any here, any here is not means this one is permitted already. Means okay, you permit first the 3, then the rest, the remaining, then you deny this range, then the remaining permit any, then the remaining, the implicit deny any will work on it. But since you already put the rest will be permitted any, even though there's a deny any at the back, there's nothing to operate on. There's no longer any IP address for it to operate on. So it's always the leftover. Think about it this way, when you provide the access list. Is that okay, Kelvin?
okay.
Yeah. So to summarize, to Farah and Noel, this access list operate on the IP address single or range. Then what is the remaining IP address? Then you apply. Then what is the remaining IP address? You apply again. Then at the end of it, any, maybe some, maybe none, IP address remaining will be applied the deny any. Deny any is implicit in the access list. Okay. Right. So let's have a look at problem 12. Says here, oh, there's no topology. Write an extended list to deny addresses from that range 172.22.75.8 through 172.22.75.127. Okay. From sending data to the 172.18.50 network. I think it's still working on the same topology. Deny the first half of the address from, okay, this is the second one. Deny from this network, second half, 127, right? And then from reaching this network. Permit other traffic. So the third one is permit any. Okay, so let's look at the first one. 172.75.8 until 127 from this network. So let's have a look. So which router? Router C. Router C. Here.
Should be.
We are talking about 75. So 75 is here.
Oh, it should be B.
B, yeah, router B. Should be router B. Then interface 01, correct? And then access list 111. Now, the thing is we're applying on the same what or if it's a continuous problem, you shouldn't reuse the access list. Is that okay, Calvin? Can you maybe put a different?
Okay, can different routers have different access?
Is this different router? Okay. All right, but then it should be okay because different router. But just for your own what lah, so that you don't confuse. And that's okay. I forgot this one is router B. That one is router A.
Then
right?
the earlier one, oh never mind.
So it should be okay because there are different routers. Then we need to do permit first.
The first half thing.
Yeah, this is the half, the 127. You have to permit the range, right? 172.22 to 75.8 to 172.22, 75, 127.
But the question only got deny only.
Yeah. Oh, sorry. Deny. Yeah. Deny. Oh, okay. So this is the deny part. So 8.
Yeah, deny half.
119. But what about 127? 8 to 127, 2 to 127.
8 until 8 plus 119 equals 127, right?
Okay, let's work it out first lah. So if I put in deny, deny. Okay, why don't we permit first until 8? Because it only starts from 8, oh. So 1 to, for example, maybe start with 0. So 0 to 7 should be permitted. So let me just put in. If not, if you just straight away deny, then maybe then the bottom part below 8 will not be allowed. So permit first that one. So 172, 168, 22, 75, 0, okay, up till 7, okay, 7, permit to 1850, right? 0.0.0.255. So we permit up to 8. And then we deny 8 to, what's the next one? So 8 to through 127. So 127 lah, up until 127. So up to 127.
And from 0 to 127. And then,
Yeah, 0 to 127. Then this one also cater for the second part, which is deny the first half. This is the first half already, no?
Yes. So no need to repeat.
So no need to put again. So but actually what we do is from 0 to 8, we allow, because the range is between 8 to 127. But then he said again, deny half of the address. So until 127. So from 0 to 127, since we already allowed up to
But-
8, then 8, up to 8 is okay.
But the second one says it deny until different network.
Oh yeah.
Deny
Oh,
from different network.
oh
So
yeah.
do I repeat the deny? The interior deny?
Oh yeah. Yeah, you're right. Hang on. 75 to 7. Oh, that means it will be denied. If we don't do anything about 1 to 7, it will be denied anyway, right? So this one can be the second one, 192. Okay, so this handle the 192 network. Then,
Then what happened to the first?
yeah, kan? The first one is between 8 to 127. So that means
But yeah, the first one
that means we still need to deny, right? Using this one. Yeah. So we still need to deny that part. We permit the range from 0 to 7 and then deny the rest up to 1 to 7 because it says deny the address from 172.22.75.8 through 172.22.75.127 from sending data to the 172.1850.0. So I think that this cover that part. Yeah. Then this part covers the second part, which is deny the first half of the address from 172.22.750 from reaching the 1620 network. Then permit other traffic. Then should be okay. Is that okay?
Oh, okay.
Noel and Farah?
Okay.
Okay.
All right. So 58, 59, 58, 59. Let me just find 58, 59. Problem 15 to 16. 15 to 16. Right. So this Farah punya is extended access list problem. So 59 to 15 is '59 to 58 to 59. Problem number 15, right? This one. Yeah, 15 and 16. All right. So it says write an extended list, access list to permit ICMP. Okay, this one we have the ICMP keyword there. Traffic from 192 network to reach this 172.16.125 network. Okay, and 252.250.2.0 network. Deny all other traffic. Oh, okay. So let's do it. This is extended. So where should we put? Well, hang on. Let's decide first. Deny accept from this network. So this network denied from going into this network. So we block at where? source, right? Should be, because this one denied to go here, so block here lah. Right? Can you write down, Farah? So router should be B from this network, means this interface FA0/1. And then you can choose any access list number between 100 and 199. Yeah. Interface should be FA0/1. Yep. And then access list number, any access list number between 100 to 199. You choose. Okay. So now, yeah, 100 is okay. Then access list, type access list, and then the value you put access list 100. Permit. We want to permit ICMP, right? So permit ICMP. ICMP is the protocol that want to, yeah, ICMP. And then the address is from this one, 192.128.45.0.
Dad, can I go?
Yeah. Okay, so the wildcard will be 0.0.0.255. Because we want any traffic from there, then. And then destination will be 172, this one, 172.16.125.0. And wildcard same 0.0.0255. Okay, so the next one is also ICMP access list 175 permit. So same kan from here, because it says N. So from 192.128.45.0 wildcard 0.0.0.255. And then we type this one 10.250.20 again, because of subnet is 0.0.0.255. Oh, sorry, it's destination. This is destination, yeah. So source is 192, same from above. Still the same as this here. Just the destination is changed. Yeah, just copy down the paste in front. Okay, so that's it. So we permit SCMP from here to here, and we permit SCMP from here to here. Actually, that's what the question is asking. Okay. So and we're done with the problem. This is problem 15. Okay, can you, yeah. And then the next problem is problem 16. Right. So in this one, problem 16 is using a name access list. So you're given the name here. To deny, this one we deny telnet. Okay. Telnet port number is 23. Telnet is using TCP, right? So we want to deny TCP from this to this, right? So we type this and wildcard will be 0.0.0.127. Okay, and then destination this with wildcard 0.0.0.255.255 equal telnet port number 23, and then we permit any. So, all right, so let's do it. Router should be, oh yeah, hang on. From 10.250 from here through this. So we block at router B because from source from here, so we block at router B. This from here lah, this interface FA00. Okay. And then access list, it's actually access list name because they're given us the Peggy, what was it? Yeah. Access list name Peggy's lab. Yes, thank you. And then enter. So you need to specify first that the access list is Peggy's lab, so IP access list extended. You have to type first, Farah, before that. Before that, you have to type first IP access list extended Peggy's lab. Before extended is actually access list. IP access list. Yes. Then after extended is the name of the access list, Peggy. Yeah. That will bring you into the name ACL config. So enter. Now you can put below it. We want to deny, right? Deny. So deny TCP. No need already because we already inside because we use the name Peggy's. Yeah. Straight away can type deny because we do this one, so we don't have to identify with like this anymore. Right? So deny TCP because Telnet is using TCP, right? TCP, and from that address, which is this one, right? Yes. And so wildcard because it's a half of the address, which is up to 127. So we use 0.0.0.127 as a filter. Just must match the up to 127 only. So and then space and then we want to deny to reaching this one. So 192.128.45.0 wildcard will be 0.0.0.255. And then equal because we want TCP, and what is the port is equal EQ space EQ, right? The port number for Telnet is 23. Yeah. Okay. So then next is to permit other traffic. So permit any IP any. Yes, and that's it. That's complete. All right. Okay. So is it okay, Farah?
Okay.
Yeah. Okay. And Kelvin and Noel, okay?
Okay.
Okay, on that, yeah. All right. So this one already marked, yeah. Router B also. So we go to number 3. So number 3, Kelvin is still doing. So I'm gonna check on Farah's answer here, right? This one, part 2 be here. So Okay, let me just do that part. Right. Question 3.2 says write an extended access list named HalfNet. So yeah, that's correct. IP access list extended HalfNet. That's correct. And then it says to block laptop 0 from receiving information second half of usable addresses from this one. So deny actually it's not only TCP. He didn't say TCP, so it could be any traffic, any traffic, Farah, not only TCP, because it's not specific to any application. So could be IP. We can put IP there. Yeah, any traffic, because it didn't say. It says only receiving info means all type of traffic. So instead of TCP, for all type of traffic is IP. Yeah, right. So and then this one. Okay, so because we only want the second half. Second half is starting from 128 to 254. So you put instead of 0, if you start 0 and 127 means 0 to 127. If you start from, if only second half means you start from 128. Okay, here 128. Sorry, yeah, 127. 127. 128. Sorry, 128. You want to start from 128. Second half, not the first half. If first half, you put 0. If second half, you put 127. Sorry, 128. 128. Okay, fair. We want the second half. So we're not starting from 0, we start from 128.
So should I like change?
Yeah, change it to 128. Yeah. Now, why? Because if you want the first half, then you start with 0, wildcard 0000127. If you want the second half, then start from 128 and then wildcard 0000127. Right. Okay. So horse and this one correct. It's only one horse. Is it one horse? Yeah. Laptop 0 is a particular horse. So yeah, you can use the keyword horse to indicate this is a single IP address. So when you put horse there's no need to put wildcard because there's no filter anymore. It's a specific IP address. Right? Okay. Permit other traffic mean then you have to add permit all other traffic mean permit any. Okay. So where should we put this? If we should put this in router B, correct. So indicating the router B is correct. And then which interface? Interface. Maybe I should here. Router B interface. You don't have to put all the. You only have to choose one interface. So laptop 0 is here, right? And want to block from receiving information from second. So from receiving, so that means originating 192.168.44. 192.168 here. So the router, because from receiving means originating from here, so we have to block at router B. So traffic from here will go to this interface G01. So this one, you block at the source, then you don't need to have this, this, and this. Okay, so you can just delete those part, and then IP access group halfnet in is correct. You can delete this yes. All right, so that's N. Okay, excuse me, a couple of minutes. Kelvin, your question is the test until here? Yes, until ACL. Okay, that means coverage, yeah? Correct, Kelvin? You're asking me about coverage, yeah?
Yeah.
Yeah, until ACL. Okay, so done already, Farah punya. Now let's check Kelvin's answer.
Oh, Noel did mine.
Huh?
Noel's answer.
This one? Oh, Noel answer. Okay. Write and access list number 30. Okay, so when the question asks you that, you have to use that. No, you cannot select your own. Allow PC3. PC3 is here. To telnet into router A. Router A being this one. Deny all other telnet traffic to router A, which must be explicitly written in your access control list. Use suitable keywords in the search. Indicate the router interface and direction to apply the ACL. Okay. Okay, so our access list is that, and then all right, access list 30.
Who got class before this? Kelvin
Permit host.
or both of you? Oh, okay.
Okay.
Also, okay. We wait for Kelvin first.
Why do we have two hosts here?
Okay. So in the meantime, last week, Miss Paula,
We apply this on router
what is
A,
the
which is correct.
last?
So this is correct.
Which
already
practical are you
Not sure
all
why
in?
why we have this
Last
one.
week, last practical, last week 7. Last week 7.
This is
What is the last practical that she taught you all? Practical 6. Oh, okay. Practical 6, Okay, hold on. Let me open up.
You're putting this one right?
Practical
You're putting
6.
because this one. The interface, is it?
In the Google
no need
Classroom,
to put
she
interface.
mentioned that you all need to submit the practical right after you all done it.
Access list 30.
So I've seen practical 7.
Except
practical 7.
yeah, you don't have to. So this one on it.
Let me share you all the screen.
because we denied any, and that's it.
Okay, practical
That means you already
7.
permit this one, then the others
So
you deny,
last week was chapter 6.
right?
Now
And
it's
should
chapter
be at
7.
interface
Should be your practical and your lecture
G01.
slide should
Yeah.
be
They ask for
the
interface.
same.
Yeah.
Should be similar. If
G01
you all learn
with,
sorted list,
IP
then you
access
can go
group.
in for the practical for sorted list.
Access
If
group or
your
class.
lecture is behind your practical, you cannot attempt to do the practical unless you do a quick
For
revision
number
or an early
standard,
revision on your own. Then
is
we
it
can
access
proceed
group
with
or
the
class?
practical. Okay, then you don't have to wait for the lecture.
So for telnet,
So sir got confused here. If chapter 6, if chapter 7, actually this is chapter 7. Sir edit this file. Chapter 7,
okay.
week 7.
That's why. If you use
So
that
chapter
one,
7
you use
is not
IP.
recursive. Recursive
Okay.
is chapter 6.
But if you don't use IP,
So sir change the
you
tab
straight away
deck
permit
to chapter
host,
6.
then no need to that.
So
no
now
need this
should
one also.
you all learn chapter 7.
Then
So chapter
deny
7, you all
any
already finished. So supposingly, why did she
correct
ask you all to submit practical 7?
in deny in. This one I'm not sure is it class or group?
Chapter 6 is recursive. Chapter 7 is
I think
sorted list.
I think it's class.
Okay.
And then because we are not using extended, right? We're not using extended, so we cannot use equal.
So chapter 6 is recursion.
telnet
Should be
port
we are
number.
able to look
So
into
additionally,
chapter
you have
7.
to
Now we will do practical 7. Supposingly,
put
we should
in
do practical 7 and a bit
like that.
chapter 8, practical 8.
So you have to go into
Chapter
the
8 is about
routers
algorithm for searching,
line
but
BTY
we haven't
04,
gone
which is
through all
actually used
the
for telnet,
search algorithm
and then
again. We haven't gone through the search algorithm, all of it. We just went
and
to
then
2 first.
you can
Okay,
apply
so
it
the
on
others
Okay.
we should continue
Remember,
next week.
because
Then by next week we should be able to
we
finish
actually filtering just a single
chapter 8. Chapter 8,
you know, this
8A
application
and
which is
8B.
telnet. So
Chapter
usually
8.
we use extended access
So you all
list,
should
name
be
extended
able to do the practical for
extended list
searching
lah.
and
We use extended
sorting.
list since this is
Okay.
not extended because using
So
number means we cannot put equal
okay, have you done?
something,
Have
right?
you,
So
Noel? Have you done
to do
your
that
practical
for
7,
telnet,
or you
then you have
guys
to do this.
at practical
Any
7?
other, I think you cannot do this lah.
Have you done the
Any
practical yet
other
with Miss Paula?
service, any other
Practical
service you have to
7,
use
not yet.
extended. So this is a bit tricky lah, this question.
Right. So this
So
one
okay, not you guys. This part
haven't yet.
this one is
Okay,
tricky
so
lah.
this one should be practical
Because you need to block this
6.
for
Correct,
I mean need to do some
Practical
filtering
6.
block and also permit for but this one need extended, right? Since we're not doing extended, then we do like this.
Okay,
Right.
chapter 7,
So I
practical
think we
7
covered
haven't
all.
yet. So
All right, so
chapter 7 you
later I
haven't
will
done it.
create
So now we will
the
we
meet,
proceed with practical 8.
and share with you guys.
Okay.
It automatically
Practical
invite you
7.
lah, kan? So we'll use that meet, and we will use
Correct,
we will use our
practical 7
current
sorted list. So for this
is it okay?
practical,
We use our
we
current Google
proceed
Classroom,
with
or do we need to
practical
create
7
a
sorted
different
list. Okay.
Google Classroom? I don't mind creating a new
Right.
Google Classroom.
So Caribbean
Maybe,
is having trouble with his connection. So never
If
mind.
I create
Okay, we proceed with the
new Google
practical.
Classroom, just submit. You have to check for your invitation, lah. Right? I will
Okay, I
invite
share you
guys
all the
for the Google
material
Classroom
for
for
practical.
our midterm test only, lah. If not, I'll reuse our if we don't receive any
wait,
invitation for Google Classroom, that means we use our current Google Classroom lah to conduct the midterm test. means your submission there. Yeah. Anything, you just PM me. Okay. Any questions on that? Are you guys okay?
Okay.
Use current GC also can. Okay, then I use current GC. Attending 2 classes. Oh, sorry, it's 2 a.m. at 2 a.m. already. Okay. I'll release you guys. Right? I'll open the earlier 15 minutes. Okay, thank you, Noel. Thank you, Kelvin. Thank you, Farah. See you later.
Okay.